sides. That's like adding something to the both sides, or dividing both sides by the same number. Just taking the square root. So what am I going to write here? Well, if I got really picky, I would write square root of 20. Because as soon as you take a square root, it turns into an estimate. See, the only square roots that you can write without saying it's about equal to is the square root of 1, the square root of 4, the square root of 9, 16, 25, 36, 49. Those are the perfect squares. 1 times 1, 2 times 2, 3 times 3. As soon as we have something like the square root of 2 or the square root of 20, it becomes an estimate. So you came up with what? 4 point what? Here? 4.7? Okay, so this is about 4.7. See, if you took 4.7 times 4.7, it's not going to give you 20.
No, 4.47.
Oh, 4.7. Even that times itself isn't going to give you 20. It's going to give you like 19 point something. Really, really close to 20, but not exactly 20. And there's a time and a place for exactness. Here we can say it's about equal to this. There will be other times when it's got to be exactly like that, and we'll let you know when that is and show you why. But we're still missing something. Look in your notes, because I did some of these for you, and you wrote them down, I hope. Griffin, just because you don't have your paper doesn't mean you can't be tuned in. Tune in. So look in your notes. What are we missing from a problem like this?
Oh, is it in the negative too?
I'm sorry?
Is it in the
Yeah, it's going to be a positive and a negative. So did you do your homework? Oh, you didn't do it though. Yeah, so this is going to be a positive, and it's going to be a negative 4.47. You get two of them, because you can put a negative value in here and multiply it by itself and still get a positive 20. So you get two answers when you take the variable out from underneath the square root symbol. So then number 6 was 6a squared equals 72. And I see you guys have the answers, but how you get to them is what I need. I need that as well. So if we're going to lay this out line by line, inverse operation after inverse operation, what's the first thing to do? So if it's parentheses, exponents, multiplication and division, addition and subtraction, we're working. Is there addition and subtraction?
No.
No. Is there multiplication and division?
Yeah.
Undo it. How do we undo multiplying by 6? 5. The same thing, both sides. And then rewrite it. So what's 72 divided by 6? What did you say? 12. Okay, then it looks just like this one. We're going to take the square root of both. And then what's the square root of 12 about? You had something. What do you get for this?
3.46.
346. Okay, there you go. That's all. But I want these steps drawn out here. And then don't forget, that's one answer. What's the other answer?
Negative.
Negative. You have your calculator? Graph this one. X squared is equal to 20. So how would you graph it? What do you guys are punching on buttons. What are you doing? So you're doing y equals x squared? Oh, okay. So you get y equals x squared. how do we put the 20 into the graph though?
Well, that's how you,
So you guys have y equals x squared graph, that's correct. So in this case here, you changed the 20 to a y. So now what you gotta do is you gotta graph y equals 20. And then you look at where they cross, where they intersect. So once you have that graph, oh no, you apply to, you're going to change the number. You can always just go to zoom and then see the standard. Now you need to plug your y equals 20. Go back to line. Oh, 20 is outside the window. So go to zoom and zoom out. So 20 is outside of your window if you're on a standard window. You zoomed out. How are you doing back there? Yep, and then do y equals 20 for the second function. Good. Let's go back. Let's see what you want to do. Let's see what you want. So, those look okay. See plot 1 is turned on. Use your arrow to get up there and you can turn off. Nothing. Okay, so now you've got the y equals x squared, the 20 is off of your grid. Maybe you sort of zoom and then zoom out. And you can enter. Right, you don't have to count everything. So there's your 20. So the intersection of that line, so go to zoom and zoom out. Yours is okay. And you hit enter. Okay, so that horizontal line is y is equal to 20. Can I see what you're doing?
yeah, yes, I think so. I had it back.
What are you texting your dad for?
This is truck stuff there, you know what I want. I didn't want to come get it right away.
Ah, it's no big deal. You can drive for a long time without oil in an engine. Then zoom out. I need to zoom out. There you go. So you have 2 points of intersection. That's what we want to see. So with this one, you have 2 points of intersection. You have a positive and a negative. This one, if you graph this, you're going to have 2 points of intersection as well. Okay, so then here's what I want you to do. I want you to finish the rest of this lesson master. I didn't assign anything on the back, did I?
No.
Yeah. Can we do this before you just cut loose on it? Maybe we look at one of these and talk about how to get after the problem. Maybe just 11, which is Emily dropping a ball from a ledge in the loft on her home, which is 13 feet above her family room floor. And how long is it going to take for the ball to hit the floor? So one thing that, like Fontenot and I will both, he's gone, I know he's retiring, but the new teacher, I'm sure she'll be the same way. In science, teachers, they do this, and we do it in math as well. When you get a word problem like this that you can draw a picture from, it is oftentimes helpful to draw a picture so that you can identify where the numbers are coming from that you have to plug into your equation. So at the top of this paper, it says use the equation distance is equal to 16 multiplied by t squared. So distance is feet, time is seconds, t is seconds. And so if Emily drops a ball from the ledge in the loft of her home, which is 13 feet, yeah, that's pretty straightforward. This is 13 feet. Here's the ball. It's going to fall, right? It's going to fall a distance of how far?
13.
13 feet. So if we just come right over here, do we know how much time? No, that's what we have to find out. So all we have to do is write the equation, and once you have your equation written, then you just trust the algebra. So we have these procedures. The procedure is to get t all alone. So what are the steps for this one?
Is there any addition, subtraction?
There's no addition and subtraction.
Multiplication?
Can we undo the multiplication?
Yes.
Yeah, by dividing. So now you got 13/16. Do not turn it into a decimal. That's equal to t squared. I'll show you how to work with this in a moment. So now what do? The square root. We're going to take the square root of the whole fraction. So when you use your graphing calculator to do a square root, and you start typing underneath the radicand, you want to just rewrite this as 13 divided by 6. So you're going to do the second key, and then you're going to find where that square root key is, and then you're going to type in 13, and then divided by, and you'll see that everything stays underneath the radicand, 16, and then all you got to do is hit enter for equals. And it's going to give you the positive value. Does a negative number make sense for the answer? So just like your calculator gave you a positive 4.47, but we know there's also a negative, will it make sense to have a negative square root of 13/16? Why not?
Because you can't have negative times very often.
Yeah, we don't talk about negative time very often. You see, if this thing gets graphed, I showed you this the other day, it's going to look like this. Sorry, not real clean. It's going to go right through the origin. But this back here, these are negative times. These are positive times. And we're looking at this going to the floor faster and faster and faster. So what do you get when you do the square root of 13/16? Push it through. Let's see if we all get something that's the same so we know that we're getting answers that make sense. You do what? 0.901. So a little less than a second, huh? Everyone gets this? Comes up about 0.901. So we can just say that it's about 9/10 of a second. So a couple of those problems, they drew a picture for us. And cats are known to always land on their feet. Are you a cat person? 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 Got a split in the room. My brother got in trouble when he was a little kid with cats. They heard that cats would always land on their feet, so they took him up into a tree house that they had built out in the woods. And they started dropping the cats, land on their feet, and they threw them higher. It wasn't very nice, and then they threw them down. And then my dad found out what was going on, and my brother was in big trouble.